Hello everyone, welcome to this new video of Gyanve. So in the last video of chemical engineering thermodynamics, we observed that thermodynamics works between the two equilibrium points. It has nothing to do with the path through which the change is taking place. So it works from one equilibrium point to the another equilibrium point. So in this video of Gyanve, we will learn about the equilibrium, how this word evolved and where this concept came from, we will see all about this today in this video. So let us move with the history of equilibrium. So in the early years of the development of blast furnace technology, blast furnace technology is typically used to make the iron Fe2O3 react with carbon monoxide to form the iron plus CO2. So when this reaction was taking place in a furnace, scientists observed that there is still some content of carbon monoxide was observed in the product, and the 100% conversion was not attained. So like a normal person, they thought that this may be due to the less contact time between the reactants. So they thought to increase the contact time. So how to increase the contact time? So they thought, let us increase the height of the furnace. So when we increase the height of the furnace, reactant will take more time to come out, and hence we will get the more product. So then they increase the height of the furnace from 5 meter to 10 meter, 10 meter to 20, 20 to 30, or even 40. 40 meters means more than the half of the height of Qutub Minar. So they made the furnace of 40 meters even. But then also they observed still there is some content of carbon monoxide present in the product, and 100% reaction is still not attained. Then they realized the concept of equilibrium, that any reaction cannot go beyond the equilibrium conversion. Any reaction cannot move above the equilibrium value. So this was the concept behind the equilibrium. So when there is no change take place, when there is no tendency for the change to take place, then that point is known as the equilibrium. So this was this is like this we can see there is very big blast furnace. So there are different types of equilibrium. In the mechanics, we learn about the stable equilibrium, unstable equilibrium, neutral equilibrium. There is the concept of equilibrium in physics also, hydrostatic, radiative, secular equilibrium, etc. There are the concept of equilibrium in chemistry also, chemical equilibrium, dynamic equilibrium, solubility equilibrium. Even the students of economics and biology also learn about equilibrium, like competitive equilibrium, economic equilibrium, genetic equilibrium. But we will restrict ourselves to thermodynamics, thermal equilibrium, mechanical equilibrium, and chemical equilibrium. In the thermal equilibrium, it is attained when touching object within a system reach the same temperature when delta T equals to 0. When a hot body and a cold body is kept together, and when the temperature difference between them becomes 0, then we can say the thermal equilibrium is attained when delta T equals to 0. In mechanical equilibrium, it is the state where no physical change can occur. When sigma F equals to 0, we can observe sigma F equals to 0. There is complete force balance. Then we can say there is mechanical equilibrium. Similarly, in the chemical equilibrium occurs when the reaction and its reverse reaction progress at the same rate. Means the conversion is not varied, means the reaction never proceed or go in backward direction. So there is the equilibrium means there is no change in the conversion. So this was about chemical equilibrium. So here in this graph we can observe that the equilibrium is achieved and there is no change in the conversion after the equilibrium is achieved. So when there is no change in conversion, then we can say that chemical equilibrium is achieved in our system. So that's it from today. For today, in this we learned about the equilibrium. So for more such informative video, you can subscribe our channel, and for more help in chemical engineering, you can comment us below in our comment section. Thank you very much.